YouTube stream, come on. All right, cool. Hey, everyone. Just adjusting my mic. Okay. So I'm just gonna start off doing the stuff that I normally do, which is the physics studying. Central with the first. How's it going, dude? I did 1 through 3 here off stream. I want to use the answer to 3 though, because it's a really important one for the other questions. I want to reread the question first though. Hey, good looking. Oh my gosh. Were you just playing today? I can't talk. Tea is still too hot. Twice. A bit earlier? Okay. I haven't played DayZ in weeks and I miss it, but every time I want to get on, I've just missed the queue for day one and I haven't felt like playing anything else. But I'll hopefully get to it next week. Played twice in about a month? Dang. You've changed. Been doing Cherno. Ooh. Have you found like a winter Cherno server or are you just doing like normal? Normal? Okay. It's that time of year that I want to do winter Cherno, but the only one I know is Zero on the... Actually, the population right now is pretty good. Maybe I will get a good chance to play it without having to wake up early. I guess we'll see. Do the winter item, but not the full. Oh, okay. I saw a lot of people were liking the autumn Cherno. I never played it though. Can't beat full winter. Yeah, I mean, I don't know, for winter Cherno, it's always like a nice change of pace, but it's never how I want Cherno to always be. Can't talk to anyone gaming through you guys say your voice. True. You are a famous streamer. Well, I mean, that was crossing my mind too. I wasn't going to say it out loud though. I was going to message you or something. But, you know, if you're going to say it, then, you know, it's not on me. Hey, Pink Couch. How's it going? Yeah, that's true. What if they just every day they ban one account until like you mess up? I remember you, Pinkosh. I feel you ask that every single time. Okay. What about for part C? Actually, part C I feel okay with because it feels pretty intuitive that there's like two lengths of string that are becoming or that are going up or down by the same amount. So over in the single string situation, you have to have twice of that distance. You got one account except for have to log out of Steam. It opens up by itself, but your VPN doesn't. Oh. Oh my god. I thought that if you try to use a VPN with DayZ that it just like tells you no. But hey, look at it this way, you're keeping the devs afloat with having to keep on buying more copies of DayZ. He's a shit one maybe? Oh, okay. Hey Suna. How's it going? You oh, fair enough. I have never used like a key buying site. To be honest, I don't really know how they get the keys for so cheap that they can sell them cheaper. I'm doing good too. I just watched Zach do his like PhD like defense. That was super cool. I got to like log in on Zoom and watch. Um yeah, this is the mechanics setting. On Saturday we were doing the E&M like group, but since it's like a normal mashing, we're just doing mechanic stuff. You get for one part of the world cheaper. Make sure you get the global one. Oh, that makes sense. All right. Have I solved all math yet? I have, but I'm keeping it a secret. You know, if I just give away the answer, then that's no fun. I'm sure you're about to solve all of math too, though. Respect it. Are you still just like going through your classes? Are you able to do like more like focused ones yet, or are you still doing super like random stuff? Do they have a diagram for part D's answer? No. Like here, the coding cell minutes of treatments exactly. It's like, yeah. It's not unethical, it's just good business, you know? It's level one. Oh, okay. Did they talk about it on levels? That feels like it's a I feel like it's like RuneScape where you have to like grind at it. Then she'll be level 99 biology. I hope not. Level 3 is a full degree? Okay. Well, that'd be funny if it was like 99 levels though. You'd have to get like 40 PhDs or something, make them add up to 99. Gotta beat a boss every level, yeah. Huh. Okay. I can go with part D. I still don't like fully wrap my head around it though. From next October, you'll be biology focused. Oh God, so you got a ways to go still. Okay, the first 5 problems are foundational. I haven't done 4 or 5, so maybe we'll do those two. Oh my God, I have to like cough 1 second. And then I'm going to go back to doing the multiple choice questions because I was doing the multiple choice question. I realized I don't like know any of the things that they're asking about. And I think you're just supposed to do these first 5 before you do anything else. And that is very unintuitive. So this involves figure 4.15. Okay. Let me get a screenshot of this. Earth science and geology. Ugh. And I never found those super interesting when I mean, I haven't learned about it since like 7th grade or something. But at least when I took it then, I never found it very interesting. Also, like igneous rocks or whatever. It's boring but easy. Okay. Fair enough. No math in this entire module. Hey, it's a plus for, you know, the non-math enjoyers. Oh, yeah, that's true. If you're going to be testing up more later, then that's going to be... You have to learn it, and then you're going to unlearn it. What's a fraction again? Well... Oh, shoot, I'm not showing the right screen. Pro streamer here. You know, if you bake a nice, delicious pie, and you don't want to eat the entire pie in one sitting because you're a reasonable person, you just cut out a fraction of the pie. What flavor is the pie? I'm trying to think of a disgusting pie flavor. But, like, I feel like you can put everything in a pie. I was about to say, like, tuna, but people make fish pie. That's a thing in Britain, right? Laxative. Yeah, okay, that's a disgusting pie flavor. Laxative. Yeah, it's a nice laxative flavor pie. It's got the nice pink, like, Pepto-Bismol color, too. Is that what Pepto-Bismol does? I don't actually know. I've never taken it, but... Sounds American. Oh, yeah, it probably is. It's just a very bright, like, pink medicine. I know it has something to do with digestion. I don't know exactly what, though. What force on the rope must be exerted by the person figure 4.15a in order to hold up the block, or equivalently to move it upward at a constant speed? The rope wraps twice around the top pulley and the bottom of the bottom pulley. So the segment of the rope is attached to the center of the top pulley is essentially vertical. I think it's going to be a quarter of the force due to gravity of the lock experiences, because each of these ropes, the rope has to have a uniform tension, but there's 4 of them coming up. Excuse me. Why is this being so weird? What? Dude, is something wrong with my tablet? I think we're okay. I updated my computers my computer to Windows 11, and I don't think I tested this part of it. VFX Genie 23:30. I got a math test tomorrow. Oh, geez, good luck. Applied math is painful. I'm not gonna lie. I'm gonna go to sleep. All right, good luck. I love applied math, but you know, it's not easy. I might have to reinstall the driver for this thing. It's kind of laggy. Oh, dude. Are you kidding me? I'm gonna unplug it. Well, no, I'm just gonna run the software. Okay, make sure that still runs. And I'm gonna unplug it and plug it back in. Okay, you know what? Plugging it back in fixed the lag. Who knew? No, it's still happening a bit. Oh, dude, this is terrible. The pressure is different as well. This is writing way thicker. Dojo drummer Gojira? Hell yeah. I love him. How's it going? Hey, Fembucks. How are you doing? Oh yeah, they were. I never looked up their performance, but it's awesome that they like got that opportunity. How's the voice? Okay, well, when I just said that, it started to get a little hoarse, but overall, it's way better than it was before. Yeah, so I still can't stream for a super like long time, but it's way better than before. Oh, thank you for the follow, Dojo Drummer. Welcome in. I wonder if the same, assuming that I'm right here, I wonder if the same thing is true for a rope with mass, because I didn't realize that's just kind of free, like, force that you're getting just from using pulleys and stuff. Okay, so this is all part A. So with part B. The person with mass M stands on the block, shown in, oh. I assume the trap answer is the same thing, but you just add the two masses. I think there's going to be like a Newton's third law issue here, I assume. Because the person is going to pull themselves up into the air, I think, but then they can't pull down anymore if they're in the air. I assume this is an impossible situation. No, maybe it's not. I don't know. Guys saying pull, you have to transform by covering up some elements. Oh, really? Yeah, that's probably a good call here. Like looking individually at just the guy and then individually at the block. You know, my diagram here isn't perfect. I did just realize that there's only one rope actually connecting it to the block. I think the logic still applies, though, that I used. I hope it does. Convert to kinetic slash potential, make sure your intuition works. Yeah. At least for this chapter in the book, it's only supposed to be like Newton's three laws. But this is like kind of like me trying to relearn mechanics, so I wouldn't mind going for an energy interpretation too. Um, oh, sailing. Okay. Yeah. That's I guess that's basically what's happening there, yeah. Except you're not in danger of free falling, I guess. All right, so I guess we probably want two diagrams here. It experiences an upward force from the tension, a downward force from its own weight due to gravity, and another downward force from the person's weight due to gravity. What force is required to keep it in equilibrium? Yeah, exactly. Like to stand still or to be at a constant velocity. So yeah, I guess static. Oh, I mean, I was doing it like two separate diagrams. The person only has a downward force of mg and then an upward force of the same tension, because tension has to be the same for a massless rope. Let me go put my mug away. I'm all teed out. That would cancel the person's force down. Okay, wait, yeah, this is so the person the rope is pulling the person up, but the person is pulling the rope down. Is that what you're saying? You get in a bucket and pull yourself up. Yeah, how does that work? Force between you and the base mass. Oh, yeah. Okay. I mean, I can see where if you pull yourself, someone's honking their horn. If you're pulling yourself up, there is some, I guess, normal force from the block. Hmm. Pull yourself up 1 meter without acceleration, convert to kinetic equal to 0 and potential. Am I counting mg twice? Yeah, it might be. Um, yeah, I think it is more about the second law. I am just like, I'm really weak on actually using the third law though, and so I'm worried that I'm drawing this wrong. And I assume the third law is important for drawing it, but I've been pretty lost with all of mechanics to be honest. So, um, third law applies to force exerted into an object. Oh, actually, I should make that 4t by the same reasoning as part A. Danu's on over a year. Clonk, how's it going? Um, so if I am trying to do this, like, it sounds like Dojo Truma, you're saying, why isn't this thing? There we go. Um, just to do an example scenario where you pull yourself up by 1 meter. And I assume we could just make it like I'm traveling 1 meter per second. I guess they need to be equal. They're asking about holding up the block or stay at a constant speed. Either way, the net force should be 0, I think. Oh, I mean, I think for the constant speed case, they're assuming you're already at that speed and you're just maintaining it or something, or like we're neglecting whatever force you would need to start moving. So I guess if the kinetic are the kinetic energy, I guess would be 1/2. Both the blocks are moving. And I mean, if we're saying velocity is 1, just to keep the numbers simple. And then we, rise up by 1 meter. And time running out of room. Yeah, I'm just I'm not sure how to use the energy interpretation, and if I do it the energy way, I want to figure out the F equals ma way of doing it too. His point would create an equal force on himself. I think maybe that's the idea, because as you pull down on the rope, the block pushes you up. Maybe, oh, that sounds important. I guess so, yeah. And so actually in that case, I said it was going to be the trap answer, but maybe it is just a quarter total mass times gravity still. Yeah, I think implicit with the question is that you're pulling at a like smooth, constant rate. I assume. Whereas like in the realistic scenario, you're hauling yourself up in a bucket, you'd be like, be a lot like jankier. You'd be starting and stopping. You, Fembox here saying you think they're going to be different, or like more different than just adding both of the masses. Tyler, you have a question? Oh yeah, hit me with it. Wait, so the person is being pulled up both by the rope and the block at the same time, right? What's canceling what? Like, what's our equal and opposite pairs? And at the end of the day, they each only have a single rope connecting. Which actually, I mean, that's also true of the scenario on the left. I'll open it up, Cytos. Country Tyler said he'd have a question that I want to look at, and then I want to get to the bottom of this one that I'm currently looking at. Oh no. This could be kind of funny. It's a little blurry. But maybe in a little bit we'll take a harder look at this. Assume the ratio m to m is such that the person in m don't separate. What's blurry? Okay. I noticed that, like, I've run into the same issue with Discord links where, like, if you just get the link to, like, a certain, depending on where you get the link from Discord, it'll give you the blurry version or the good version, and it's kind of weird. So it's possible that, depending on the masses, they would separate. Okay. Yeah, because if the block is super heavy and the person is super light, I think they will just climb up the rope rather than pulling the block up. Yeah. Person, you have the mass of the person and tension on the rope. Oh wait, you said you have an equation country, Tyler. I misread your thing. What's happening there? Stop lagging, please, tablet. I have to reinstall the driver for this thing after the stream. Oh, you know, I might know where this is going, but this is a different one from the one that I've seen before. Oops. Hey Joseph, are you not like this because what's it called? Of the first? So minus 7WB minus 21U. No, this I'm using a tablet. The tablet is lagging though. And then we divide each side through. Actually, here okay, yeah, I see where this is headed. Let me set it up right. I'm just gonna flip the inequality, but not actually like do anything. Hey Enigma. And then I'm gonna divide each side. Oh wait. No, I shouldn't have done that. Oh my god. I'm messing everything up. Just divide each side through by -7. And that flips the sign. And it's we heart you. Thank you, Tyler. Were you there for Zach's thing, Enigma? Oh yeah, no, you put a thing in the chat. I thought it was super cool. Sorry, it's Central. I'm just like I'm doing multiple things, I guess. I don't know. Let me catch up with what you were saying. First, you have the mass of the person and tension on the rope. First, you have the mass of the person and the tension on the rope. I think the person also has the block pulling them up. That's at least what I was intending with the normal force there. On the block, you have the tension of the rope. The block is also supporting the person's mass. Yeah. Oh, your office hours conflicted. That sucks. Just one thing I understand, although I'm not great at these. I just know a little bit, so I got excited. Ugh. Don't worry. When I watch a lot of the other math streamers, I only understand what's happening like half the time. 8 a.m. Oh, the Linkin Park lyrics. It starts with one thing. Doesn't even matter how hard you try. I'm sure Zach will talk about his defense next time he streams. Not sure what type of answer you're looking for. I think my explanation talks through the forces slightly. Pulling on the rope creates tension, also creates a downward force as a result of the pulling. If these are equal, then they cancel out, and he cannot then pull any higher. Well, I think you can pull your... I'm just thinking about it, like, realistically. You can pull yourself all the way up to the roof. If you pull hard enough. It's basically... I think the question is basically... what is it, basically? What is the downward force the block is experiencing? Because the person must be pulling with either the same force or a quarter of the force. I haven't quite worked that part out yet. And so the block isn't necessarily supporting the person's weight. And that might have to do with what Dojo was saying before, which is if the block is super massive, the person is just going to climb up the rope. They're not going to actually pull anything. And so the weight of the person might be getting canceled by the tension. Like, these two forces cancel. It is just that. That's too simple. I feel like I'm being tricked if I say that that's my answer. The normal force is probably actually 0, because it's if they were accelerating, it wouldn't be. Is the upward 4t correct in the second picture? I'm not sure. I'm not sure either. To be honest, I'm kind of doubting it for part A also. No, maybe I'm not. Am I? No, I think it's okay. I don't know. At a person on the ground, assume the person on the ground just organizes the rope. Comes off the guy. Potential energy. I'm not sure I understand that, Dojo. Organizing the rope comes off the guy, potential energy. Okay. Maybe um I the force that has to be overcome is the two masses added together times gravity. That just has to be overcome. I think the only question is what coefficient goes in front for me right now. Because the person does have to pull down, or they have to pull on the rope. Like, this person has to hold themselves in the air just in that little box there using the rope, but they also have to pull down a little extra hard to hold up that big block. And then my question is that are all these crazy ropes in the middle actually doing anything to help? Person on the ground does all the pulling. Okay. You've done it live to get into a tree fort? um Seen it done on a sailboat. Um Connected to the ceiling. Yeah. Well, okay, wait. What if it's actually this freaking tablet, dude? How terrible does that look? Because I feel like the person isn't getting any benefit from the pulley and holding up their own weight. But by the logic of part A, they probably are getting a benefit from holding up the block of mass. Feel the cube coming. I'm about to just check the answer here. I feel I don't know how I feel. um it's number 4. Check the answer for part A. The TV the tension in the long rope. Sustained throughout the rope. Yep. So the bottom pulley is massless. The reasoning problem 4.3b tells us tension is short, attached to the block is 4t. This tension to balance the mg weight of the block, so the person must pull the rope. Okay. 1/4 big mg. Good. Part A, we're good. The free body diagram is shown in figure 4.39. Congrats. Thank you. I'm going to cover up the answer on my end to part B. I just want to look at the free body diagram first. Wait, there's 5 tensions? Wait, am I right? I'm going to look at the answer. What the hell? This is... I know I was wrong. The free body diagram, 5 tensions protrude from the top of the dash box, and the 2 weights mg and mg protrude from the bottom. Wow, I kind of hate that. So my idea of splitting up big M and small m was just bad. In the case where to figure out places, you need to look at how many ropes are shortening. Okay. Dude, I thought with free body diagrams, I guess you do consider the person in the mat and the block to be one thing. I don't know. I think you're supposed to just draw like one thing at a time. Oh, I see what you're saying with the ropes that are shortening part. All 5 of these ropes are like getting shorter as you pull. What's the limits part? Dang, okay. What does number 5 say? Wait, we're dealing with only figure 4.16? Yeah. Yeah, I've learned this book, it's never the simple answer, but that doesn't help me get what the complicated answer is. but me, I don't know. Figure 4.16. You support the play system with your hand at rest. If you have your eyes closed and think that you're instead supporting a single mass M at rest, what is M in terms of M1 and M2? Oh no. Don't you know the mass for the person and the mass for the block separate? Yeah, I'm just spitballing half the time, dude. I don't know. I somehow feel like electricity magnetism is easier, even though this is actually like a physical thing that I can visualize. Okay, surely this is a free body. Like, can we just make the same free body diagram basically as in the last problem? Why am I drawing the dotted box first? I should draw the thing inside first and then make the box around it. No, I should just use the image and draw the free body diagram around that. Aha. Like, I just want to say M2G, M1G. F me. See, pulling it near the speed of light, all bets are off. You know, F me. You buying the plane ticket? Oh, come on. Am I not worth the you know, is this not worth the price of a plane ticket? It's gotta be, yes, M equals M1 plus M2. I'm gonna be mad at the answer in the previous problem, and I'm gonna want to know why it doesn't work here. Wait. No, yeah. M1, is this not an equilibrium? It's at rest. They don't say M1 equals M2. Which is potentially an issue with my logic then. Uh, um, if M1 equals 0 and there's no friction, then okay, yeah, I'm not holding anything up at all, really. Well, that's not right either. Can you repeat that question? You did that so many times, Central. Oh my god. Scrimp is saying, draw another picture with a hand holding a single mass and draw a free body diagram. Gonna do an expertly drawn hand here. Wow, you're saying M1, M2 plus M1 minus absolute value M2 minus M1. Yeah, if M1 goes to 0, it does make sense that I don't need to exert any force. And I guess it's basically the case that we have on the right. No, I'm sorry, it's not. Um, and so your formula would match that limiting case, yeah. How do I don't see how to like theoretically like justify doing something that weird. Like if we just for the sake of argument, let M2 be greater than M1. And if we look just at my beautifully drawn pulley, so this is like how I draw a person, to be honest. M2, stop lagging tablet. That person looks sus. Yeah, it is an Among Us bean. How do they look? No, I don't think. Well, how do their crotches look? I don't even know. I think it's just flat. There we go. I'm not a fan of the bulge. I think it's mostly his glasses. Yeah. Oh, you mean the drawing? Yeah, like M2 is falling, or M2 is experiencing a force. M2 minus M1 G. You were wrong on the last one. And this is the force. Wait. Yeah. The acceleration we have to solve for. Comes as a little mini gaze. Some dickhead in 17th century watching Apple fall to the ground. Now I'm watching this shit. Thanks a lot. Well, it wasn't for that Apple, dude. I wouldn't have to deal with any of this. Glad he died a virgin. Oh God, he probably did. Well, that's the force. In this case, I'm just I'm just making things like simple for myself and making that assumption for this little thing. But I think the acceleration, you'd have to take this force, and wouldn't you have to set it equal to m2a? It's an established fact, really? Okay, I'm not going to show it on stream, but did Newton die a virgin? He is not known to have ever had a romantic relationship of any kind and is believed to have died a virgin. Feels bad. I don't talk shit when I talk shit. Okay, if I am right and we solve for the acceleration here, it's not right, Ren? I believe you. I am usually not right more often than I am right. Yeah, I believe you too. Okay, the acceleration is definitely not that though. Like that's force. The units aren't right. I bet this is thrown away. It is central. Solve FAD for all relevant objects, write Newton's law for each one, then solve for F me. I guess I don't know how. Ugh. That's what I'm trying to figure out. Okay, you know what? Delete. Wait, do I have delete hotkeyed? What does this button do? I have no clue that. Oh, that does that. I don't have delete hotkeyed. Why not? I guess I have the eraser hotkeyed. Okay. Anyway, all right. Let's just do this the old-fashioned way. M1. You are experiencing a downward force due to gravity and an upward force due to tension. M2. You are experiencing an upward force due to tension and a downward force due to gravity. Me. You are... Who the hell knows what you're doing? You're pulling up with force F me, I guess. And then the bottom force is the question. Hey, exactly, Zap, and that's how I feel right now. F me. Do you on the block, you're getting slingshot into space, you skinny twat. No, dude. Twat is an underused word by Americans. It's a good word. Unite is not right. Unite is never right. So close. Like Like, I just want to say that it's M1 plus M2. Like, I don't know what else it could possibly be, but that doesn't feel right. It's too simple. Okay, yeah, you're okay. You're saying that's not right. What's pulling the pulley down? I mean, I guess maybe the pulley's the better thing to write in there. Um, the tension in the rope, that is M1 minus M2G. Oh, wait. So this pulley is experiencing whatever is left over of the total. So is that why we can do it? Like the total force kind of, if it was the single block case, would be this. But then you have to subtract off whatever the tension is that the rope is taking care of for us. No tension in free fall, right? Weightless rope. I'm wrong. I feel that. um this feels good what I've written. I'm trying to figure out if I can potentially, is the tension in the rope the difference of the masses times gravity? Wait. No, I don't think it is. The tension in the rope should be, if M1 is smaller, it should be M1. Ugh. Okay, so if M1 is greater than M2, I think the tension would be the smaller. It's always like the smaller of the two. Been trying this on my own so far. What I've done is found the force on M1 and M2 individually, then found the net force on the pulley system. Yeah, Scrim, that seems like what we should do. Yeah, because the master equal firmly give you 0 tension. Write Newton's second law for each free body diagram. Okay. M1A is equal to M1G minus, M1G minus T. M2A, I guess we need A1, A2. They should be the same acceleration. All right, but I'll keep the subscripts. Tension is 2 M1G if M1 is smaller? That doesn't sound right. My equations are correct. Well, okay. Well, the tempting thing to do here, yeah, oh my God. A1 equals A2, and I'm just going to name it to be A. Equal in magnitude and opposite in direction. Oh, yeah. Okay. So maybe we actually want to do one of these bad boys. It's really tempting to eliminate for one of these variables. Hey, Phobos. If we get T seems like it would be good to get rid of. M2G plus M2A. And if we go over to the left and plug it into that one. M2G plus M2A? How are we doing, Phobos? And presumably the helpful thing to solve for here is A? Or A1, I guess. I'm doing too many steps at once in my head. Okay, let me get a A1, A1. M1 plus M2A is equal to M1 minus M2G. A1, I keep dropping the subscript. So A1, M1 minus M2 over M1 plus M2G. That seems like a thing. Hey, famished. So yeah, I guess the pulley itself, the point you're making is we can simplify its free body diagram. Oh my god, please stop lagging, tablet. To like not even include all that garbage. But if the pulley is massless. Oh my god, the best viewers are back. My Automod actually caught that one though. So, like, this is the acceleration that the pulley needs to worry about. What is the mass, though? I guess like that? Use a dummy mass? Writing equations of lines? Ooh, nice. Like, is that like homework that you're doing, famished, or what do you mean by that? To figure out the true force pulling the pulley down. Pulling the pulley down, you're good. um then okay, we're giving the pulleys at rest, right? My hand is at rest, but that means the pulley is at rest. Are we saying that 0 is equal to F me minus the acceleration we just got times some dummy mass? You say, but it's a course? Okay. No? How does one master all of algebra? Probably a lot of practice. I don't know. What's pulling M1 up? The tension in the rope. So what's pulling the pulley down? Oh, the tension? Is it twice the... Only one tension, not twice the tension? Twice? Okay. Yeah, because there's two ropes coming down from it, I guess. Okay, dojo. Um, everything you need to solve for F me. Okay. F me is equal to 2t. And t, I guess we want this guy with A1 subbed out? This, I hope this cleans up. Okay, the dimensions check out? This number is less than 1? Which is it? Not, why is M2 more important here? Like there's an extra M2 floating around. That doesn't feel right. It shouldn't be more important, I don't think. Did I make a mistake somewhere else? This is right? I can simplify. Um, does getting, oh, maybe getting a common denominator inside the parentheses helps? Um, 2m1. Oh. Oh. The M2s cancel, right? So we get over M1 plus M2. Okay. So we end up with 4 M1 M2 over M1 plus M2 G. What the hell? All right, Ren, you're a god. I need to say that off the bat. This is called a reduced mass. They're making this shit up. Famish, I have no clue. I won't say that I'm even close to mastering math. I feel like there's not many people who would say they have. Huh. Okay, I'm glad it wasn't something like. I'm really glad it's. I mean, I haven't checked the answer, but I'm glad it wasn't the really lame like that thing. That's where the math was Hilbert. Yeah. Until we get near the speed of light. This is simple. Now look at it, dude. It's literally two masses on a pulley. Why does it have to be this complicated? So next week, if I go through my course, I'm not psychotic. I feel like if you want to master math, you need to be a little psychotic, though. You can choose almost any like famous mathematician and read all the weird shit that they've done in their life. All right, let's look at what the book says about this. Okay. The various parameters defined as in figure 4.40. 4.40 t a is defined to go that way. So you get a math arrange these into your phone number 1 through 30. Yeah. I mean, that assumes my phone number uses each digit once, though, right? You know, you might have given me an impossible task. You're an impossible task? I am. Oh, they eliminate A. Okay. Oh, okay, yeah, it is simpler to solve directly for T, right? I did it in a roundabout way. Wow. Yeah, thank you so much, Ren, for like guiding me through that. As well as that everyone else was like helping along the way too. She doesn't count down using number twice if you need to. I feel like I've heard you talk about countdown before, or maybe I feel like I've heard someone talk about countdown, but that's like a game show, right? I don't think we have it over here. So I'm gonna hear like Zelda Ocarina of Time. I never played it through for myself. I like it, but Pen Center is the one who really like is grinding it. He hasn't streamed recently, but like Danny Highway too. Oh yeah, the Hey Listen. It's just like it's fitting for the stream, I guess, to get me to like listen up. The parallel. Oh, that is a version of that. Yeah. It's called the or it's nearly the harmonic average. I think the actual harmonic average has a 2 on top. Going back to Netflix. Too many sweats in math and physics. Hey, I mean, dude, you've been here for like an hour or something, sweating it out with us, so you can't pretend like you're superior. But enjoy your Netflix. Once the randomizer with me, I set up. I'll need to look into it. They're not that hard to set up. I haven't done one for Zelda, but I've set up like emulators up a couple times, and it hasn't been too bad. Didn't understand anything. Ugh. Either way, have a good night, man. Where M1 is very small, can ignore M1 in the denominator. M is about 4M1. Oh, okay. Really? I guess so, yeah. Well, that's weird to think about with their bowling ball and marble example, but I guess it works, yeah. And then question B after that, nothing? I mean, I've been struggling here, so I'm not judging. So it should make sense. All right. Neat question. It's annoying that it take that much work, though. Okay. So these are the 5 foundational, excuse me, problems that the book sets out for chapter 4. Let me go back through to the multiple choice, because I was trying to do the questions in order, but these multiple choice questions really rely on 1 through 5. So what multiple choice question did I leave off on? 22? I don't know if I checked it. Either way, let's move on. No, I mean, I don't... did I check it? I definitely checked 20, so I got the one wrong. No, Let's just think about 22 anyway here. Lincoln Lawyer? Oh, yeah, I've heard the name, I think. Probably better than math. Yeah, you can say that about a lot of things, I think. Conservation of string relation for Atwood's machine shown in figure 4.11. All the acceleration defined to be positive upward. Kind of like Suits, but it's nothing like it at the same time. Perfect. Okay. Okay, if I got this one right, it was by a miracle. Never heard of Suits, then kind of never speak to me again. Oh, you actually put that you're joking. I'm surprised. I've heard of Suits, but that's mostly thanks to you. So it's like I thought I hit pause by accident. All right, you fuck off too. This is such a problem worthy of being stared at. So I think this pulley is going down at A3 over 2. I guess minus A3 over 2. Well, okay, it depends how I draw the arrow. Either way, if the mass on the right is going up, the pulley on the left is going down at half the speed because there's 2 strings. Silverbird. Oh yeah, I think we're making that assumption for all these here. The context is that I'm trying to relearn mechanics. And so I've been going through this book here. And so at least for the stage that I'm at in this book, like they're just introducing Newton's 3 laws, so we're not doing anything too crazy yet, thankfully. Oh, that's not the right section. Oh, by the way, welcome in Silverbird. I do think the more I think about it, I think I did check the answer to this question, and it is B. That does mean that we're getting a factor of 2 somewhere in here. Or I guess a factor of half on the other side, maybe. Like there should be some kind of relationship. Minus A3 over 2 is equal to something involving A1 and A2. Don't we know that A1 is equal to minus A2? Is that not a thing? Hmm. Why is the expression in the middle pulling minus A3 over 2? I mean, I might be missing something from A1 and A2. Actually, that's probably the key there. But I was thinking, when I wrote that, I was thinking only about like the upper part of the problem here. And for every length that the right mass goes up, D, on the left side, we only get D over 2 length because there's 2 strings. And so I think you have to cut your acceleration in half because of that. The more I think about it, the more I'm probably missing. I need to also combine it with something involving the bottom system here. So actually, we could use if if we're allowed to use the answer from the problem we just did, then I think that means that minus a3 over 2 well, I just found physics programmers who program stuff related to physics. Sounds way. Oh yeah, you should check out FizzBuzz. He does actual like physics programming streams. I agree though. I find coding to be tedious a lot of the times, but there are some really cool things you can do with coding that I am interested in, with like doing simulations and stuff. But yeah, like for really like you can do programming related to any field of science you want. Math, chemistry, biology, all of those things. Okay, you know what? Maybe we want which we want. So you want to get into you like having options? Oh yeah, that's fair. If you just like learn the libraries for like scientific computation, you could apply it to a lot of different fields. Um, I think A1 always equals minus A2, because I think we usually assume that the rope is always like taut, or like, it's always at its full length. So if they weren't equal, you get like either the rope is breaking or you're getting a lot of slack in the rope. And I think we don't allow for either of those scenarios. So I think this result from the problem we just did is probably helpful. Equal and have the same sign. I agree with equal, but if they both have the same sign, then both the weights are coming upward based on how we've defined positive in this problem. They're both coming downward. That's the point. Uh, I mean, what if you have a huge mass on the right side? Well, okay, you know what? Maybe I see what you're saying, though. Then they'll both be going upward. I think we're talking about different, like, situations. Maybe that's the issue, because when I'm saying A1 equals minus A2, I'm talking only about the bottom pulley in this system. A1 is minus A2. But I think what you're saying is right, where if we then involve the entire system and look at the accelerations as a whole, it's starting to look like a person. I think you're right, where like the net acceleration, it's not clear to me if they're always agreeing with each other, but they probably usually would. Yeah, what's the question? Critical. Okay. Well, maybe I'm just thinking about it wrong because if I am right about that, then that means A3 is 0 here, doesn't it? So maybe I am thinking about A1 and A2 wrong. Dynamic of college, but it gravity force at each point of interest. It's gravity for the three masses, and there's the string tensions. Yeah. Hey, Reaper. Hope you're doing good. Hmm. Not too bad. That's good to hear. I'm doing good. Um, so on stream today, I've been doing some of this physics studying, and then earlier, another math streamer, E22I Pi, is a PhD student, and he just did his like dissertation defense, like the final stage, and I got to watch that on Zoom. That was cool. But yeah. Hey Milk, it seemed like it went well. It was interesting stuff. Yeah, it was today. I started my stream like just a little bit after it ended. They booted us all out when it came time for the actual committee to ask questions. But so I was only able to see his presentation and then the general audience questions. But I like, you know, to me, it seems like he did a really good job. So posted it? Okay. Mass are equal because the tensions are equal. Since the ropes are stretched, N1 equals N2, assume the bottom pulley is flowing acceleration A4. Okay. Let me look at Critical's question, but I think I agree with you that they should have the same sign, I think. Hey, Gizmeist. I studied applied math. Is this a line integral critical or what? What are the directions here? Oh, this is weird. This is a Windows 11 thing. I have my Discord split across two monitors, and one of them is more zoomed in than the other. Yeah, it was mostly about like modeling, using differential equations. So we did a tiny bit of partial differential equations, like the heat equation and the wave equation, but there's a lot of emphasis on like systems. I thought it was really neat. You really want to get in that field? It's cool. Okay. Let me get Paul on the phone. I should be able to do this, but I'm gonna have to remember how this works. Oh, nice. You're probably asking the wrong person because I have not been able to get a job related to my applied math degree. So I have a hard time saying like, yes, it's a good career, but I mean, I've been a tutor, but that's not like what most people would want to do for their career. But actually just over Thanksgiving, which was last week here in America, because I'm not sure where you are. I was talking to my cousin who has worked at for many positions in the federal government, and apparently applied math is really in demand. Like like the CDC is like modeling the spread of diseases. The Department of Energy is like projecting energy use. And there's many things apparently in the federal government that like where applied math is in demand that I'm trying to look into more like right now. You know, I'm not saying there's anything wrong with doing tutoring for your career. I think that many people don't regard it as their like career goal though. From South America. Oh, cool. So yeah, I'm not sure what opportunities. Oh my god, I'm not showing my. I mean, I'm not. I thought it was on a different screen, but yeah, I bet there's still something out there. But I can't say I know much about like, you know, how in demand mathematicians are in South America. I'm sure there's still a place like somewhere for you though, where they go, I just kind of fell into it, built super well. Yeah, I mean, there's a lot of upsides to tutoring. So I'm not throwing any shade at all on it. How are we doing this conversion? Use Stokes Theorem to evaluate. Let me look at the actual example problem. I know, I feel like I should have better intuition for this based off the E and M. But I don't. Oh, this is the reverse direction. So we take the curl F. How do I get the bounds? I'm not that far yet, critical. No, it's all good. I say that's tutors I have ever had didn't mean to be tutors. They said other things in the path, got them into the teaching field. Oh, cool. Ren was telling me that it's really basically Stokes theorem that we use to explain the displacement current result around that loop using Ampere's law. Oh, really? That is cool. This is Paul's online notes. It's my favorite website for everything calculus. I mean, I like the page that I'm on for Stokes theorem, but just like look through the if you're trying to get through like a calculus class or know someone who is like, I really love how clear and simple their explanations are. So I'm trying to figure out curl F is just a formula. That's not that hard to calculate. How do we have a parameterized ellipse and we need to convert it to a surface, like just like a regular function like x plus y plus z equals 1. Sometimes you don't even use curl F. I think they're asking for us. I mean, my interpretation of this. Oh. Hey, Longsword, welcome in. My interpretation of this is they want us to say... They want us to evaluate f.dr around the loop using Stokes theorem. I think means that we convert it to that surface integral. And so if you have other situations where like it said to use Stokes theorem and you end up doing something weird, then I don't know. Turns out everything about the difference between Gauss' law over closed surface on Peir's law around a loop. Yeah. Oh, I guess so, yeah. When we were pushing that surface around different places, that was basically Stokes' theorem there somehow. Huh. Okay. To do that with electromagnetic field? Okay. I didn't quite right. Comes in that displacement current term. Okay. Yeah, sure. Punching. I'm working on some from critical thinking first, but I would definitely welcome the Maclaurin series question as well. The only thing that I'm stuck on right now is how do we convert the parametric equations into a surface? That's what I'm trying to work out right now. And that's what you're asking about with the bounds as well. Okay. Yeah. The curl's usually the easiest part. Oh, you have to be clever? Oh, that sucks. Okay. Who likes being clever? Uh, hey, math major. The surface should be a plane restricted to the ellipse boundary. Um, does this ellipse exist in one plane? I think it's tilted. Maybe? Y does equal z here. Maybe it's not tilted. Find the normal vector. Huh. I think there should be like ideally I want to find a trick like in this example problem where you just notice to do y squared plus z squared and find it's equal to x squared. That's the type of thing that I'd like to find here and avoid doing too much work like getting a normal vector. Oh, we could. Oh, you know what? I think it goes through. If z equals y, then imagine an ellipse in the xy plane and tilt it up by 45 degrees. I think that's what it is. Hey, Anders. And hey, Freddy the consumer? Mass on slope equations? I'm not sure what that means. So it'll be 2 pi and 0? I mean, I feel like the actual bounds of the integral are the thing that I'm worried about here. I don't know what the heck to put in for ds. Oh, I think I'm getting closer. We could say x squared plus y squared equals 1. X squared plus z squared equals 1. And make these simultaneously true. Add them? Oh, that'd be nice. Yeah, 2x squared plus y squared plus z squared equals 2. Oh, Freddy, I'm really weak on that stuff. I'm sorry. Yeah, my voice is definitely a lot better. I don't want to stream for like a super long time, so I don't mess it up, but yeah, it's definitely a big improvement from how it was. Interesting. That looks like the right shape. It's just the constraint that y has to equal z that I don't know how we would capture there. The problem is here, Anders. We have to convert a line integral into a surface integral with Stokes theorem, I think is what they're asking. Oh yeah, Freddie, I dual stream right now. The Twitch chat is a bit more active. Um, yeah, Fembox. It's only like Critical knows how to do the curl part already. Yeah, it doesn't seem like there's a universal way of doing this. I'm gonna be honest, I don't remember ever learning Stokes theorem in a class. I think my multivariable calculus class stopped at Green's theorem. Oh yeah, Freddie, that type of stuff I can do. I think so, critical ice. I don't remember uh having to do Stokes theorem or a divergence or curl or anything as an undergrad. I mean, maybe I did and I just don't remember it, but yeah. I'm gonna Google this. So I don't know. I don't want to like just keep staring at this, trying to figure it out when punching is also waiting. Um, that's what I wanted to do, Fembox, but it's an ellipse, and that means we also need to change the f function, and I don't know how to do that. This is not going to give me the results that I want on Google, I feel like. Okay. Yeah, Dr. L. I don't know what S is the problem, or I don't know what DS is. I mean, I don't know how to solve for DS in this like case, Anders. Hey Cook. Pressure equations for the surface. Differential equations for the plane. Freddie, I can answer those, but I want to focus on this problem first, and then I need to do Punching's problem, and then I can try to explain your questions there too. Sorry, I'm not ignoring you. It's just a little like I can explain it quickly, but I want you to know that I'm not ignoring you. Oh, thank you, Melissa. Leibniz theorem, that's most of DS. Shape is the intersection of a cylinder and the plane. Ooh. Yeah, that's an interesting thought, math major. See what that's like. Reinforce it with R and theta. Ooh. It's getting spicy. It does seem like spherical would help there, but oh, that's what you're saying with the normal vector earlier, math major. Thank you, Freddie. How many viewers on Twitch? Right now it's 20. Anyways, I think I just don't get this. All right, sounds good, Freddie. See you for now. Why don't I use ChatGPT? Because I don't trust ChatGPT. Um, I'm not going to understand this quickly enough, I don't think. Punching, are you still around? Do you have your question? Because I think I'm stuck on this one. I'm not good enough with Stokes's theorem. You posted it? Okay. Yeah, I'm gonna switch to punchings. If people still won't talk about this one after, then I don't mind. But where did you post it? Punching? I don't see it. Oh, in the elements? Okay. I see. Number 6. Screw Stokes and his theorem? Yeah. Yeah, Pamux and I were just talking about that idea, Cook, with the displacement current. It was getting weird because it seemed to like you have to do it differently depending on what service you choose exactly, but you get the same result. Okay, so the first non-zero terms in the Maclaurin series for the function. Is it basically fundamental theorem of calculus? I guess so. I haven't studied enough, right? Evidently. All right, so we're looking at 6. This one, at least I know how to do. This is basically just a formula for the Maclaurin series. It's from n equals 0 to infinity. What do we have? The nth derivative of f divided by, not c, n factorial times x to the n. So we have the general SN formula for it. So they cancel use a trig identity. Oh yeah. There is the trig identity. Sine 2x equals 2 sine x cosine x. That probably makes it a lot simpler rather than having to do the product rule a bunch of times. So we'd say this is 1/2 sine 2x. So yeah, let's, I guess, we'll start by getting our derivatives. That's why I messed up. Okay, I messed up the formula. It's at 0 because it's a Maclaurin series. It's not x. So I should actually back up and get f of 0 before I move on to the derivatives. So sine of 0 is 0. So we're not going to get a first term. And that's why I'm asking for the first 4 non-zero terms. So now let's take the derivative. It's going to be cosine of 2x. And so f prime, of 0 here is going to be 1. Get our second derivative, 2 sine 2x. But anytime we're gonna have sine of 0, we're gonna get 0 for the actual value, so that's not gonna count for a term. F triple prime. It's a little bit of a tedious problem, but we could just look at the pattern here and see it's always going to be 0 or 1. Oh, I mean, if you're allowed to use like a known expansion. That's what you were thinking? Okay. Shifu, can you review optimization? I can link you to a page that reviews it, but I need like a specific problem to go over. But if you want some practice problems, I will use Paul's online notes here. Come on. And so rather than just taking the derivatives a bunch of times, I think we can say that it's going to be like a power of 2. Oops, I messed that up. 4. Oh, I messed that up too. There should be a negative sign there. Thank you. There we go. So we're only getting odd terms because it's the first derivative goes with n equals 1, the third derivative goes with n equals 3. Two to the 2n. It'll be something like that. Like I'll treat that as like a good base, and then plug in some test values to check it from there. I think we're getting even powers of 2 though. So yeah, we do have an alternating sign, and we start positive, and we're starting from... Oh wait, I'm sorry, they're asking for the first 4 terms. We don't need to do n for anything here. Oh, but you're looking for the... okay, never mind. Let me... You're trying to find the general pattern. We could skip over finding the general pattern. But it doesn't hurt to do it. So if we're starting with n equals 0 and we want to start positive, minus 1 to the n should do the trick there, because negative 1 to the 0 is positive 1. And then, oh, you could take the negative terms and do them separately, but I think that sounds like it might get a little bit messy. Oh, yeah. I think what you have, negative 1 to the 2n plus 1 is not quite right, because we can do exactly what you say there. And say it's negative 1 to the 2n times negative 1 to the 1. Negative 1 to the 2n is just positive 1, though. It's negative 1 to an even power. So you just end up always with negative 1. So you don't usually want to do negative 1 to the 2n plus 1. Or to the 2n. It's not usually a helpful thing. That was the general series. The -1 shouldn't have a power like that. That's weird. Am I crazy? Okay, no. You might have an offset. Okay, so we're taking care of the signs that are alternating. The next things to take care of is that we seem to be getting powers of 2. Oh my god. We seem to be getting powers of 2 there. But it's not every power of 2. We go from 1 straight to 4. So 1 is like 2 to the 0, and 4 is like 2 squared. So it looks like we're getting even powers of 2. So I'd say 2 to the 2n is what we get there. And we're going to divide... This one gets divided by 1 factorial, then 3 factorial. So 2n plus 1 factorial times x to the 2n plus 1. That's, I think, our general Maclaurin series. I think if I was a student taking a test, though, I wouldn't try to write this out. It feels like it's maybe a little more trouble than it's worth. When they're only asking for the first 4 terms. And from this work here, we've already found the first 2 terms. So I don't think it's that much more work to just get the next 2. But this way is possible too, and if you prefer that way, then you should do it that way. But yeah, now that we know this kind of general form, we can just do n equals 0, 1, 2, 3, and those are our first 4 terms. So when n equals 0, we get just x. When n equals 1, we get 4 over 3 factorial, which we'll simplify, x cubed. When n equals 2, we get positive 1, 16, 5 factorial, x to the 5th, and then one more term, we'll get a negative sign. This is n equals 3, so 2 to the 6, 64. 7 factorial, x to the 7. And actually, maybe I'm lazy and I don't want to simplify these fractions. We could, but the signs are all negative. They shouldn't be. I don't think so. Because when you're taking these derivatives, every time you take the derivative of a cosine, you're going to insert a negative sign. So there should be some alternation. Oh, okay. So does that make sense, punching? Okay. Yeah, I think I do like the just kind of like brute force way of doing it more, but that works too. Janino or Nino the gnome? Oh, that's probably Nino the gnome. Thank you for the follow. Okay. So Critical's question is posted to the Discord if anyone does have an idea later. I think I'm calling it quits on that question for the night though, or at least for the stream. Was there someone else in Twitch chat who had a question? If not, Freddie in the YouTube chat earlier was asking. I need to explain some things. Find a permutation for S? Yeah. He's working on it too. I guess my plan right now is I kind of want to address the question that Freddie asked earlier in the YouTube chat, and then maybe call the stream. If I'm interested in like looking at your fun problem though. If it's too involved, I might not have the really like the voice to do it today. I'm already getting a little bit hoarse. Polar coordinates, u of rt is equal to r cosine t, r sine t, r sine t. Really? Where does that come from? You know, I thought it was an ellipse, but it actually is a circle when I try to plug in t equals pi over 2. Yeah, Cook, like, the thing I didn't get about that is that wouldn't you have to change the vector field? Like, if you're going to warp the surface, you have to warp the vector field in the same way, don't you? Hey, Hanyolo. I wish I understood Stokes' theorem better, because I haven't been able to do it. Yes. It's XYY. All right, I still don't really know how to use it. Let me look at what Freddie's questions were. %90% same average and flunked the exam? Oh no. Setting 3D rendering Mobius transformations wasn't. Oh no, that sucks. Jerry63, thank you for the follow. Okay. Okay, let me find a page here. I'm gonna. Oh, wait, let me actually. Okay, well, let's do the fun challenge problem first. S be a finite set of points that any triangle made from 3 points in S has area less than or equal to 1. Show there's a triangle of area 4 which contains S. Oh no. We know about math is don't drink and derive. Yeah, very true, Jerry. Welcome in. I feel like I've maybe seen a problem, that exact problem before, or a problem like it. I don't remember anything about it though. I don't think I was paying attention. Um, could you look at like what's like the I assume you want to figure out whatever the worst case scenario is that has the points farthest apart in S and containing that. No, there's probably a simpler argument. There's probably something you can do with just like squares or rectangles, I bet. Um, hmm. Yeah, I'm not sure how to do that. Well, let me. I want to at least give a pretty little explanation here for their questions, but I still have some semblance of a voice, and then we'll see what happens from there. Um, why there? And then Freddie went on to say, okay, let me type in chat to make it easier for Freddie when they look through the VOD. Okay, so I think it's easier to address the second question first here. And that explanation is basically if you have a plot of time and displacement, and let's say it's any function you want, it doesn't matter which one, as long as it's like smooth, like this for our purposes. When you go to take the limit definition of a derivative, before I get into the limit, let me just give an intuitive explanation where if you agree, and hopefully you do, that if this is distance versus time, the rate of change of this curve at any point is whatever the slope of this tangent line is. So if I want the rate of change here, it's whatever the slope of this is. And the rate of change of position with respect to time is just velocity. Like that's how we've defined velocity to be. It's how fast our position is changing. And so if we were to actually go to the limit definition of a derivative, and there's different forms of it, but the explanation is the same. Actually, it's easier to see with the other one. And I'm realizing my notation is confusing here because I'm using time. Okay. Let's say that point happens at t equals a. So the limit as t approaches a. See, this is where things get weird because we usually write f of x, but here we're using x and t. So technically we have x of t, but I guess I'm going to use that because that's what I just did. But the limit definition here is x of t minus x of a over t minus a. And all this is x's are distances. And t's and a's are times. So distance divided by time, like meters per second, that's speed. So that's how it kind of comes up organically from the definition of a derivative. I kind of like the more intuitive way of thinking about it, where it's just the slope of the line, but these do ultimately mean the same thing. And then on to the first part of your question. Like, that's just kind of just because. I don't think there's a particular reason for it. And just to be clear, you only get the negative sign when taking the derivative of cosine. The derivative of sine is positive cosine. But the derivative of cosine is negative sine. And that negative sign it's just kind of there just because. I don't know of a particular reason for it. We could compare the graphs, and we could also, you could be a real Chad and do the actual limit proof. It's a little bit of a pain. But the simpler explanation is that the graph of cosine looks something like that, and the graph of sine looks something like that. And you can create like a correlation between points on the sine graph and points on the cosine graph. So right at x equals 0, sine is 0. And then looking at cosine, at x equals 0, cosine experiences a peak. That's a slope of 1. Or sorry, slope of 0. Whenever you have a peak or a value, you have 0 slope, just a horizontal line. And that slope of 0 is the exact value of sine over here, 0. Whereas if we look at cosine on this part of the graph, we get a negative value, like a negative slope. But here sine has positive values, so that's why we need the negative sign to flip it. So they have the same value at the same point. So yeah, I would say it's like, you kind of need the negative sign to make the graphs match, and it just kind of, the negative sign just kind of appears. Like it's not, as far as I know, there's not like some deeper meaning or anything more to like dig into there. See, I hope that helps, Freddie. Yeah, I think that's all I have to say about it. So radius 1. Yeah, math teacher, like, that's what I was wondering about, like, that's what I'm going to deal with. Like, you could theoretically have some, like, really obtuse triangle that's nearly a flat line, but I assume you could engineer one that is of area 1. It's hard to even draw, but, like, I assume a triangle like this with area 1 is possible. And that kind of made my first idea of trying to find the worst case scenario not really possible. And so I assume there's some more, like, elegant way to make that 2 over b, yeah. When other points in the set violate the conditions. Oh, yeah, I guess I see what you're saying. Like, what other points would S contain? Yeah. I don't, Oh, I mean, I'm sorry I didn't do much for you critical, but I hope that Penbox fan and Dr. Cook uh a little bit. I'm gonna all right. It sounds like there's some it sounds like Anders is still working on typing something up as well, and Math Major put some ideas in there too, so oh, 1 or less. Okay. Oh yeah, I missed that part. Hey Kevon. Nothing much with me. How about you? I'm just thinking about this problem for Math Major before I wrap things up, I think. Um, I want a hint, I guess. Han Yolo, are you okay if a hint gets put in chat? Or do you still want to think about it? I think I'm correct? Okay. Yeah, I guess hit me with a hint. No matter what S is, can always name a triangle of area 4 to contain it. I guess the real argument is that it's not S doesn't have some weird like shape that a triangle of area 4 can't necessarily contain. Like S can never be shaped like this. Because I feel like even with my weird triangle example, like it's still pretty clear that if the area is 1, you can always name a slightly bigger triangle for area 4. I don't know. Social concentration, I can't even count my age. I mean, I always have to think about my age when people ask. This is a bound for S. So you want to take the circle of radius 1. And then draw another triangle around this. And that's like the centroid thing, I guess. Yeah, what do we know about a triangle? So if I take this big triangle to be equilateral, I assume that's the point. I assume there's a relationship between like that length of 1. Well, no, it's not necessarily 1. It's definitely not 1. Little triangle's a quarter of the big one. Flip the inner one upside down. Oh, duh. I was just thinking to myself that it looks like a triforce. Yeah. Okay, so the triforce is the correct answer. I mean, so these are equilateral triangles, though. This feels like... Does this argument work for any triangle? You can make the triforce on a non-equilateral... Okay, yeah, that... Because I don't know how this argument works for my extremely obtuse triangle. Um... I don't know what the radius of this circle is. I guess... Yeah, I don't like... I guess I still don't know why this works. I don't have a valid answer, but my insomnia is cured. uh. Dude, that's a great tagline for the stream, curing your insomnia. Oh my gosh. I'll put you right to sleep. Don't you worry, Jerry. Um... I don't see what you're saying, Hanyol, with that set of points not being able to exist. In S? Because if you do have even like a weird case like this, like the set S would just be the triangle. Oh wait, yeah, no, and everything inside it. Like it's your limiting case. That's how I was imagining it. Take any triangle, a scaled up triangle with 4 times the area. Oh. Okay, so the circle thing's maybe a bit of a red herring. Just make 3 copies of it and make the Triforce. Okay, okay. Yeah, okay, yeah, Math Major, I like that. So yeah, for any triangle I can give you, take as long as it's like, as you say, the largest possible area, you can always do this process of copying it 3 times and making a Triforce. The baby triangle. This is how baby triangles are made. You bisect each side and then you connect them. Yeah. How many works did Purcell Morin? This week and next week, Cook. Last week was our first one on Maxwell's equations. I am failing at studying mechanics though. It's taken me way longer than I thought to understand this. So I don't know. I've been slacking on it too, but yeah, I've not been able to speedrun the mechanics like I thought I would. The end of a Purcell Morn area is coming up. It is. All right, that is a neat problem though, Math Major. Thank you for sharing it. Taking it towards the end of chapter 5, the Blue Moor mechanics text. That Triforce is messed up. I tried my hardest, Phobos, but yeah, it is. No, I just wanted to do it with an obtuse triangle. This is Triforce under a linear transformation. I'm sure Penn Center would love that. Zelda plus linear algebra. Sean Putnam exam 2016. Oh, nice. All right, I think I'm gonna start to wrap things up here. There's been a lot of new faces today, so thanks everyone who has popped into the stream. For anyone who doesn't know, I'm not the only math streamer out there. There's a whole bunch of them. Those are the ones that I can recommend like the highest. Everyone on the list is math help in some form. Putnam exam website has formal. Okay, nice. Yeah, I've heard of Putnam problems. That one seems like simpler than they often would. I've been guessing at Math Twitch and I see it growing. Yeah, it's a really cool community. It feels like it's growing like slowly but surely. Where like it's cool to see like someone pop up in someone else in someone's chat and then like kind of like make the rounds to a bunch of other math streamers and kind of like settle in with the ones that they like prefer to watch or the schedule works the best. Watch games, my brain rots while I hang out here and learn things. Nice. Glad to hear it. What do you call me? Let's see. What did I call you? Oh, it's... Yeah, I remember this. Oh, it's not showing up right. Sorry about that. Too late now, though. Let's see if there's any friends or anyone who's doing math out there that we can go say hi to. Oh, shit, I'm gonna cut the YouTube stream off here. So if you're on YouTube, thank you.